Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 6th. I'm Mark Sponsler, and I'm your host for tonight's presentation. I'll be leading you through our discussion about weather over the North Pacific, jet stream, wave models, surface level pressure, and of course the long-term forecast, including discussions about the MJO and of course El Nino or La Nina. Guess we'll see. All right, let's get into it. Looking at significant wave heights for the North Pacific Ocean, we see a pretty calm pattern. Again, fall has yet to actually kick in. Small area seas here, what are they, about maybe 10 feet aimed at Hawaii. That from a gale previously north of the islands. Actually, it was low pressure that generated some seas. We'll get into that in a minute. Tropical system developing. Tropical storm Hagibis in the far west Pacific Ocean, providing perhaps some hope long term. And then another non-tropical cold core low off of Kamchatka, generating 26-foot seas, but basically all aimed at the Aleutian Islands and bound for the Bering Sea. No hope there. Let's get into the detail. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet, and there really isn't one to be found. We'd want to see the jet like here in the Gulf. We want to see it falling south. Now here's part of kind of what was a trough. It was a cut-off trough. See, the main energy flows pushing off Japan, then ridging hard to the north through the Bering Sea, and then pretty much over the Alaskan coast into Canada. Okay, but you really want to see the jet dip south. That helps create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure, and of course low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. And swell, when it hits your beach, normally produces surf. All right, so right now we don't have really any troughs. We have a ridging pattern, the exact opposite of a trough, and that helps set up a clockwise flow aloft, and that's the hallmark, and down at the surface, that's the hallmark of high pressure. And yeah, you can get wind swell from that, but you're not going to get long period swell. You're not going to get the sort of swell that is typically associated with fall and winter months in the North Pacific Ocean. All right, so let's go on our hunt looking for a trough. Anything that could helpfully give us something that resembles surf. And we're already into Wednesday. Here's another one of these I'll pull that away there, these cut off troughs. The wind flows south, but the main flow is still up to the north. And then it quickly just sort of gets pinched and cut off. That doesn't do anything. We're into Friday night, Saturday, another cut off trough. See, the real issue here is the energy pushing off Japan is instantly going northeast. That's driven by right down in here. We call the Kelvin Wave generation area. Those of you that watch this know when we get into the MJO discussion, inactive phase of the MJO is here. That just pretty much drives the jet in the wrong direction and doesn't do anything. It just pushes it to the north, doesn't impart significant energy to it, and you end up with no real surf. So here we are, we're a week out at Sunday, and again, no real change. The jet pushing off Japan, making a little bit more progress to the southeast a little bit, but still pretty much all like aimed at the Aleutian Islands, if not in the Bering Sea, and doing nothing for us. Darn. All right, so let's go take a look down at the ocean surface, see if there's any difference there at surface level pressure. Here we go, surface level pressure, surface level winds. Yeah, here's our cold core low. There's the Aleutian Islands right there. All fetch is north of the Aleutians. Swell does not pass over land and into the North Pacific. So if you're surfing somewhere up in the Bering Sea, if there is such a place, sure, great, there's waves there, but nothing for us. Remnants of that low I was talking about earlier hanging there. Hagibis here, southeast of Hawaii and developing. We'll talk a little bit about that, but you know, since there isn't a whole lot going on, you can kind of keep your eyes here, see what's going on. We're also just sort of looking for any fetch greater than, I'll say 35 knots in the North Pacific Ocean. Yeah, there's some, but it's all aimed up at the Aleutians again. Hagibis building big, starting to push to the northeast. Will it recurve? A little bit of high pressure here generating fetch, but not aimed even at the Hawaiian Islands. Hagibis approaching, where are we? We're on Friday, approaching Japan. Will it recurve? Well, the GFS model says, yeah, just barely, and then racing up off the Kuril Islands on Sunday, a week out, with a good-sized fetch of 55 or 60 knot winds aimed sort of up the Great Circle paths to California, not so much to Hawaii, and then racing off. Where we go? We're at 180 hours. This guy looks like he's bound. We know what the jet stream is doing. Probably bound for the Bering Sea. Maybe some sideband swell, but, okay, we're talking a week out. We're talking a tropical system. We're talking the GFS models, not great track record at anything more than 3 or 4 days out, much less tropical systems, which are notoriously fickle, and a week out. So the odds of this happening are, we'll say, 1% right now. But watch the models over the week and see what happens. All right, moving on. A quick look at Hagibis, its forecast track, the official track, not the GFS model, but they seem to be in pretty good agreement. The interesting part here, we see winds building to 135 knots. What's that, like 155 mile an hour winds, somewhere right around in here. But then it is the recurvature that we don't know. We don't know, even if the GFS model is right, if it will recurve or if it doesn't recurve until it gets over Japan. Too early to know, but at least you get a general idea what's going on. If you are in Japan and surfing in Japan, good odds for swell. Also good odds for some significant winds. Keep your eye on this. Start taking some precautions to protect property if you're near the coast and even inland and low-lying areas. It's definitely a good idea to keep your eyes on this. All right, let's go take a look at the wave models. And just remember, a wave model is not a model that stands on its own. It actually takes input from the previous model we looked at, the GFS model, surface level winds, and then interprets the effect of those winds on the ocean surface, and then calculates projected significant wave heights from that. And that's what we're looking at. So it's a model of a model. All right, and that should give you a little bit of sense it's only as good as the GFS model is, and if the GFS model isn't so great more than about 3 or 4 days out, then this probably isn't any better either. It can't magically do something better than what the GFS tells it to do. So, all right. Anyway, so a small cutoff low pressure system developed on Tuesday, October 1st, near the date line. Here's Hawaii here. There was some fetch and some seas, 18-foot seas, but not aimed anywhere at the Hawaiian Islands. So we'll just put this into motion. But then you see as you get into Wednesday, there was a bit of a fetch here, sort of aimed at the islands, but the low itself was lifting north. And then finally, here we go, on about Wednesday night, what is that, maybe 16, 17-foot seas aimed at Hawaii. And then about 17 or so foot seas still aimed at Hawaii. On Thursday, that low was aimed back at Japan of no hope. There we go. Fully 18-foot seas, almost 19-foot seas. Midday Thursday aimed at Hawaii. And then that continuing, smaller seas, 17-foot seas on Friday aimed at Hawaii. And then into Saturday, seas still at 17 feet and then quickly fading while the low itself falls south towards the island. So small swell is in the water and currently hitting Waimea Bay. We're not talking big. It's wind swell. I mean, seas were only 11. So you see the little bump here. So how do you read this? This is energy at each of the different periods in the spectrum, up to 33-second energy or down to 5-second energy. And then each line here tells you the height of the waves in that energy period. So the highest bump here is like 1.6 feet at 12.5 seconds. But the swell is not limited to one band. It maybe covers a spectrum here of several bands. So we have a fancy way. We'll go down the chart here. We'll slide this over so you can see it. We're going right to the bottom because that's the current reading. So we have primary swell. We calculate at 3 feet, 11.9 seconds from 332 degrees, generating waves that are about 3.6 feet at Waimea Bay, but one can interpret that as 3.6 feet Hawaiian. So that's how this goes. Small swell, and you can see the energy slowly building through the day, 11-second period, and size barely coming up, but supposed to be coming up much more by tomorrow in the islands. Nothing huge, but rideable, and that's better than nothing. So let's look at the wave models moving forward, starting today, 18Z Sunday. So that's about 11 a.m. California time over the Pacific Ocean. Gale, we know, going into the Bering Sea. Hagibis hanging down here. Let's put this all into motion. Looking for anything like 18, 20-foot seas anywhere in the Pacific. Not seen it other than Hagibis, supposedly with 62-foot seas aimed north. Well, at a Cat 5, I would say that's probably not too far off the mark. Now, you see the precarious situation that Japan's here with significant swell and probably wind likely coming close to the coast. GFS model and the wave model, though, suggest a turn to the northeast as we get into Sunday, a week out, still with 54-foot seas on about like the 302 Great Circle degree path to California. Long ways away, about as far away as you can get, but if that were to occur, some smallish, longer period swell could result. Might take, 5 or 5.5 days, something like that, to maybe make the distance over towards exposed breaks in California, if this occurs. And if it would say, hey, maybe we're starting to move into fall. But again, we're going to be pretty conservative and say the odds of this happening are non-existent at this early date. Let's take a quick look at the South Pacific Ocean because, believe it or not, summer is not over there. A small gale, this is Friday night, like 11 o'clock Friday night, last Friday. Small gale developed under New Zealand, blew up, sort of, 37-foot seas over a tiny area aimed northeast, and not shadowed by the Tahitian Islands relative to California, like 213, 214 degrees into California. So maybe a little bit of swell to result from there, about 8 or 9 days out. So not this coming Tuesday, but a week from Tuesday, roughly speaking. Look at the forecast, the long forecast we have on Stormsurf. In fact, you can click it right there, and we've posted the latest updates on swell arrival time for this swell. All right, so anyway, let's move to the future. Here we go, 18Z on Sunday. That gale fades out, doesn't do a whole lot. Another sort of cutoff low is maybe supposed to generate 26-foot seas aimed north for just, look at that, just a short little window on Monday. Doubtful, and it looks like Tahiti's sitting right in the way, but maybe a little bit of swell to result, specifically for the catcher's mitt of Southern California, but that's probably about it. Looking for anything else, another small gale, very small, forecast Thursday night, again down in the deep south central Pacific, barely 30-foot seas, some background swell might result from that, and then things get pretty quiet. I mean, the reality is we should be looking north this time of year, and we should have had some swells by now. We haven't. That's just the way it's rolling right now. Let's do a quick look at wind swell potential. Right now, not a whole lot. We're looking for winds off of Cape Mendocino. Yeah, a small patch of 20-knot winds. Due to high pressure ridging into the Pacific Northwest, not generating much fetch. No fetch east of the Hawaiian Islands, so we'll just sort of roll out. We get into Monday. Same deal. Here's that low still hanging north of Hawaii. Cutoff low, not generating any fetch. No real fetch for California. Maybe a little patch. Then somewhere on Tuesday, notice this high pressure system starts building south. Fetch starts building off the North California coast. Low pressure inland, high pressure out here produces a pressure gradient, tightening of the isobars. You start getting a small patch of 30-knot winds. So that means wind swell should start to be produced in North and Central California by Tuesday night. By Wednesday, we're practically at gale status with 35-knot winds over a small area off of North California, generating raw wind swell. Also a little bit of easterly fetch east of the Big Island, Hawaii. Maybe some small wind swell going there. So we get into Wednesday night. Wednesday night, the gradient peaks out relative to California, and you get into Thursday morning. Still wind swell, but this swell, remember, generating from these winds, passes down the coast pretty quick. You get, maybe 5 or 6 hours, and then it's gone already. Anyway, still some wind, 25-knot winds off Northern California on Thursday. Easterly fetch, sort of building east of the Hawaiian Islands, maybe some wind swell on east-facing shores there. Fetch starts dying along California, still 15 knot. You get some wind swell from that. But notice the fetch extending the whole way over to Hawaii. So by the time you get into Friday morning, good fetch east of the Hawaiian Islands, 20-knot winds over the Hawaiian Islands. All this driven by high pressure. And sure enough, that should generate some wind swell into the Hawaiian Islands. Also notice 45 knot winds over a tiny area up here in the northern Gulf on Friday. They're not going to last long, so they don't get much traction on the ocean surface. You need duration, time of winds blowing on the ocean surface to really generate seas. So no swell likely from that. East wind swell continues for the Hawaiian Islands into Saturday. Maybe some little wind swell for California generated by this fetch off the coast. But even that, again, short-lived. We're into Sunday, and then things really quiet down along the California coast. Same thing for the Hawaiian Islands. And wind swell dies out. Hopefully, the North Pacific will awake, but we'll get more into that when we start talking about the MJO. A quick look at rainfall potential we're just focusing on the U.S. West Coast. We're really focusing on snowfall potential. Yes, Whistler, looks like they're going to get something come Monday into maybe Tuesday, and then some rain and drizzly conditions for the Pacific Northwest Tuesday, even snow for the higher elevations into maybe Wednesday morning. Then high pressure takes over, and we'll just blast through this. You can see no rain, no rain, no rain. Then a front approaching the Pacific Northwest Saturday, a week out, but it dissolves. And then another one. I mean, the focus really, early season, is up on British Columbia, Whistler, the mountains in that area. Which is pretty typical for this time of year, but nothing significant down, hardly even into the Pacific Northwest. No worry, it's still pretty early in the snow season. Let's go take a look long term. What's going on with Madden-Julian Oscillation, our favorite long-term predicting friend, and then of course ENSO, El Nino Southern Oscillation. As usual, we like to look at winds across the equatorial Pacific, and specifically the West Pacific. That's where the MJO, the Madden-Julian Oscillation, has its biggest influence. When the active phase is over the West Pacific, this area we call the Kelvin Wave generation area, it can produce westerly anomalies or out-and-out west winds that then take warm water that's typically in this area, start pushing it to the east, but not on the surface. Underneath the equator, it travels the whole way across the equator over a 3-month period, and then that ball of warm water can, if it's strong enough, erupt off of the Galapagos Islands, Ecuador, that area, produce a warm water slick. If you get strong enough active phases of the MJO in quick succession with one another, that can be the catalyst to start generating El Nino. All right, so right now, winds over the East Pacific, out of the east, we're just looking at the arrows, pretty strong, but that's kind of normal for this time of year, making it to the Central Pacific, and then dying out. Now notice there's a bunch of missing data around portions here. This is from the TAO buoy array, a series of buoys strung across the equator, and the sense is that some of the buoys are down, and it's a Herculean job to keep boats out there, keep these buoys up and running, tending to them. I mean, weather, wind, birds, you name it, fishermen, commercial vessels can impact the buoys, or just you can have hardware failures and things go down, parts of the array go up and down. So not unusual to see sections of the array not reporting data. All right, but anomalies, differences from normal for this time of year. We're looking for arrows, and it looks like, you don't really have a whole lot, pretty much a normal wind pattern the whole way across until you get into the Kelvin Wave generation area. That's from 135 east to 170 west, 5 degrees north and south of the equator. See tiny little arrows out of the west. That does not indicate the active phase of the MJO. If the arrows were a lot bigger and a lot stronger and lasted a lot longer, maybe so, but basically just a neutral pattern. Let's go look at the forecast for the next week. There we go, zonal wind anomalies. So what's that mean? The east-west component of the wind. Are the winds blowing more from the east or more from the west? And only if they're stronger than normal or weaker than normal. All right? The reds indicate westerly anomalies. And this chart is the whole planet on one chart. Okay? Pacific Ocean is between about 130 east to about 90, actually 80 west, so this whole area here. But the Kelvin Wave generation area, that's the area we're really concerned with, runs from about here to about here, 170 west to 135 east, something like that. So you just go straight up the chart on those two lines. This is time down this side. And you see back in, when was that, September, we had westerly anomalies in the Kelvin Wave generation area. Then they slowly faded by the end of September, and the blues are easterly anomalies. So you got this little push easterly anomalies, and late September, early October. That's indicative of the inactive phase of the MJO. And then west anomalies tried to come back, and then for the next week, light easterly anomalies are forecast. That suggests clearly the inactive phase of the MJO is setting up over the West Pacific, and we haven't had that for quite a while. Now, the really interesting part is you look at this and go, wow, that's certainly a strong easterly wind event, and it is, but it's not in the Pacific Ocean. It's in the Indian Ocean. And if it stays in the Indian Ocean, when it kind of smells like it will, and we'll get into that in a minute, that's a sign of something else and maybe something a little bit better for us. All right, let's move on. Let's go out 2 weeks. Another way to look at the MJO is not necessarily winds, but cloud cover, right? Outgoing long wave radiation is what it's called. That is how much sunlight is reflecting off the ocean surface. If you see these oranges, it means positive anomalies. That means clear skies. That means a lot of sunlight reflectivity off the ocean surface. And that means, if no clouds, that probably means high pressure. That means the inactive phase of the MJO. And according to this, this is the statistic model, inactive phase building for the next 2 weeks. The dynamic model suggesting basically the same thing. Building inactive pattern. This is no surprise. We've talked about this for a couple of weeks now, and now we're paying the price. Good time to go do chores, take care of business, and do what you got to do, because when the active phase comes, that's when our odds for swell, surf, and snow are better. Phase diagram charts, another way of looking at the MJO. Now, how do you read this? Assume you're looking down on the North Pole, that circle there. The MJO moves on the equator from the west to east, from the Indian Ocean, over the maritime continent, across the West Pacific, across the Pacific, under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. The heavy dot right there is where the active phase of the MJO is. So that would be like over North Africa, probably eastern North Africa. And these lines are the forecasts of where it's supposed to be. These are statistic models for the next 2 weeks. So basically, very weak, traveling probably into the Indian Ocean. The exact opposite side of where the active phase is where the inactive phase is, which would be like just about ready to pop into the West Pacific. So that's consistent with what we've seen on the other charts. GFS model, saying the same basic thing. Very, very weak active phase, making its way to the Indian Ocean. And the closer to the circle you are, the weaker it is. If you're inside the circle, it's almost non-existent. So a very, very weak MJO signal. And how weak is the MJO? Well, here's sort of, this summer, you can see how weak it's been, and that is reasonably proportional to the storm track. I mean, we really were good back in June. Look at that. You had a solid MJO signal. Since then, the MJO has been weak, not a whole lot happening. Compared to, let's say, back in January 2018, we were stronger MJO. But no, look at this. Back in 2017, we were in a very weak pattern as well. And you get the idea. Here's our El Nino thing in January 2015, or the early part of 2015. Massive spikes up to like 4 standard deviations above normal. Today, we're pretty much at normal. All right, moving on. Here's the 1 month CFS model view. What do you call that? Wind, 850 millibar wind anomalies. Thank you. That is winds of about 4,700 feet, but a good proxy for what's going on at the surface. Again, Kelvin wave generation area between this point here to this point here going up. Okay. Here's past activity, which looks a bunch of westerly wind anomalies in September associated with the active phase, the MJO. In fact, there you can see it right there. Now, those westerly anomalies are fading. Here's for the next 4 weeks. There's the inactive phase of the MJO there. Still westerly anomalies hanging on in pockets, but here's the big easterly push. Supposed to max out about October 19th, making it almost to the date line, then retrograding. Once we get into November, it looks like a much better pattern to set up, but we're going to just pay the price here in October, and there's no way around it, and the models have been pretty consistent regarding this outcome. And then the 3-month CFS model, again, 850 millibar wind anomalies between 7.5 south and 7.5 north on the equator. Okay, and here is our Kelvin wave generation area right in between these two marks going up. This is past history here. Here's the future. Here is our inactive phase of the MJO. This is winds, easterly anomalies, peaking out about October 19th, it looks like, making it, but not even to the date line, just about to the core of the Kelvin wave generation area, and that's it. We can overlay the MJO here. So the dotted contours, inactive phase of the MJO. Here's where we are today. So we have to suffer through this till about, somewhere around the 1st of November. But even as we get into late October, westerly anomalies start building. Inactive phase starts fading out. Then we go into a pretty strong active phase from, November 7th through till about, the 1st of December or so, with strong westerly anomalies, maybe even potential for a westerly wind burst there. And maybe that, it'll push some warm water east, maybe, if there's any warm water in the West Pacific to push east, and then followed by another inactive phase of the MJO from, second week in December on through Christmas. Low pass filter. This is the important part. So, this is the solid contour is propensity for low pressure, or sort of like a low pressure bias. We've been hanging at about one contour the whole way through fall, which is pretty weak. But supposedly is in the next 2 or 3 days, we should move to 2 contours. And then supposedly to 3 contours as we get into, Thanksgiving time frame. I mean, if I didn't know better, I'd swear that looks sort of like a trying to develop El Nino type situation again in the atmosphere. And the model's been consistently saying this. We've been tracking the exact position of the leading edge of these contours, and they're not moving from day to day, week to week. I mean, they're pretty solid. So the model is doing some surprising things, and they're favorable to swell production in the Pacific. We're going to get into that a little bit more in a moment. All right, enough of the MJO. Let's go talk about the ocean. What's going on at depth in the ocean? West Pacific here, East Pacific here. The X's are the anchor lines on the TA buoy array strung across the equator, and these are the sensors on those anchors. You can get the temperatures, use a little bit of fancy modeling software, string it all together, fill in the gaps, and get a profile of what's going on subsurface. And we see a building pool of warm water. This is quite surprising. To the date line, it was about there last week, but just the total aerial coverage of the warm water is increasing. That's the 30-degree isotherm line, 30 degrees centigrade, 29, holding at about 170 west. The 28-degree isotherm line is at 153 west, which is, I think it's a little bit east of where it was, suggesting maybe, just maybe, warm water is pushing off to the east some. Now, here's the interesting, the 24 degree isotherm line is pushed to 120. I think it was back at about 123 last week. So some sense that warm water is moving a little bit to the east. Now here's where things are really interesting. And by really interesting, I mean really interesting. You look at this, you go, well, what's this? Okay, anomalies, differences from normal for this time of year. But if you remember last week and the week before that and the week before that, actually for the past 3 months, there's just been this big pocket of just iceberg cold water sitting under the eastern equatorial Pacific. As of right now, here is all that's left of it. I mean, even a week ago, I was saying, sure looks like La Nina, just, cold water subsurface. And the CFS model, this is what I was saying before, it kept saying, oh yeah, no, warm water's coming, and there was no objective evidence of it whatsoever. Well, all of a sudden, now there is. Look at this, we have 2-degree anomalies under the date line. There's the date, 180 west, so it's actually, about 170 or 60, something like that. But it looks like a Kelvin, there's been a steady Kelvin wave hanging here for months. It looks like it's starting to finally move off to the east a little bit, making it to, where are we now? 120 west, so that's due south of California, and looking to be on the move to the east completely, because this guy is all but gone. The cold water pocket is completely gone. In fact, here's another model. Now this goes, it's the 30th of September. You can see the cold water pocket here. But even with this one, it was the whole way back at like the dividing line between the cool water and the warm water was at 150 west 2 weeks ago, I think. Now it's at 130 west per this, and the reality is it's at 120 west per this one. And this is the other thing. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So a core 4 degrees centigrade above normal. That's almost like 7 degrees Fahrenheit above normal. That sure looks like a Kelvin wave, and it seems like it's on the move. And yet, we did have an active phase of the MJO in September, and maybe that's what just pushed and gave enough energy to start pushing this Kelvin wave loose. So let's take a look at one other thing. Sea level anomalies. Fancy word for, is there a bump on the ocean surface? Strip out all the wind waves, strip out the swell, strip out the tides. We see a positive 5 centimeter bump here, and it's just on the equator we're interested at. There's the date line there. South America there. New Guinea there. What this means is if you have warm water at depth, it kind of expands, and when it expands, it pushes water up above it. This is at depth, right? Okay, so down like 150 meters. Creates a bump on the ocean surface. That's what we're seeing here. That suggests to us or infers that there's warm water at depth, which what we saw on the other charts. We assume it to be true. And last week, it only reached to about 150 or so with a pocket at maybe 140. Now it's the whole way to 130 west. So it looks like warm water is on the move. Equatorial upper ocean heat anomalies. All right, so basically, fancy way of saying we're looking at Kelvin waves here. Okay, and we'll just sort of do it this way. There you go. So back in time, this is the West Pacific here, East Pacific here. This was a Kelvin wave from our previous El Nino back a year ago. It was at October 2018, moving from west to east, impacting Ecuador. Upwelling phase of the Kelvin wave cycle, cool water. Another stronger Kelvin wave, but not as broad, January of this year, and it made it to Ecuador. Upwelling phase of the Kelvin wave cycle, but notice this, cool water just filling. This is that whole thing we were talking about. Big cool pool in the East Pacific started in May, so that's 1, 2, 3, 4, almost 5 months of cool water building there, and it definitely looked like La Nina was trying to organize. At the same time, there was this 1, 2, now 3 stationary Kelvin waves in the vicinity of the date line. But notice now, all of a sudden, this latest one is making inroads to the east and starting to cut out the cool anomalies here at depth in the East Pacific. So more evidence that something is changing, that maybe, despite all our proclamations, the CFS model is actually just maybe getting it right. Here's another view, upper ocean heat anomalies. You can get the same sort of pattern. You know, Kelvin wave back in October 2018, then likely the inactive phase of the MJO. Active phase here, another Kelvin wave in the March-April time frame. Inactive phase, another Kelvin wave, smaller Kelvin wave, inactive phase, another, the current Kelvin wave. Now the question is it enough to wipe out the cool anomalies, or will there be this current inactive phase that's developing right now? Will it cut the legs out of the warm water that's moving east? And we'll get a little bump in water temperatures in the East Pacific, and then we'll fall right back into one of these negative holes. That's what I guess is probably going to happen. But the CFS model is making us doubt that a little bit. We'll get into that more in a second. All right, so sea surface temperatures. What's going on at the surface? That's what really matters, because it's the temperature of the ocean on the surface that interacts with the atmosphere above it, and that if you have warmer than normal temperatures, you get more evaporation. That helps on cool clouds. The clouds help impart energy to the atmosphere, feed the jet stream if it's over a broad enough area and over a long enough period of time. All right, so the point being, well, we have these still persistent cool anomalies off of Peru and Ecuador here, and they've actually built a little bit today. But there's this string of very warm water building just like 1 degree north of the equator, pretty much over this whole area that had previously been cold. The cool pool there's this finger of cool water coming off of Peru, working itself the whole way over to like 150 west, something like that. That's quickly eroding now, and warm water is filling in and building north of it. And now the question is, how long will this last? Well, we don't know. Here's the first thing that gives us a little bit of pause. Okay, so this is sea surface temperature trend the past 7 days. It was cooking warm over this whole area, reds and browns last week and maybe a bit the week before that. Now we're starting to see cooling set up off of Ecuador again. Suspect that, well, we don't know whether that's a long-term trend or a short-term trend, but with the building inactive phase of the MJO, suspect high pressure is going to start building here, high pressure building here. That'll start increasing trades in this area, causing upwelling, and you could be back in the hole we were in before. The other side of it is it could be, remember that cold Kelvin wave, if you want to call it, the cool pool that's quickly eroding off of Ecuador. This could be the last of that squeezing to the surface and just making a temporary cool dot here. So we don't know. But we do know that there's warming from about the Galapagos westward, well out to almost the date line now. Not significant warming, but some warming. And then not the trend, but actual sea surface temperatures, anomaly differences from normal for this time of year. Here's that cool pool off of Peru. But that finger, these like little waves of cool water, were reaching the whole area to like 150, 160 2 weeks ago. Significant backtracking, the significant degradation, but the cool pool still present off of Peru, Chile, and this is what kind of makes us think this might be just a temporary trend. We'll see how much this erodes over the next 2 weeks or so. So something to keep an eye on, but at the moment, it seems like the La Nina-like pattern is backing off some. All right, what's going on in the atmosphere above the ocean? We can tell by looking at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When pressure is higher over Tahiti than Darwin, the index goes positive, and that's a sign of the inactive phase of the MJO. We think we're in the inactive phase of the MJO. Daily contributions, though, minus 11, minus 20. I mean, we've been in a pretty good little negative run here the past 4 or 5 days. That does not make a trend, because before that we had about a 6-day run of positive anomalies, but not very positive. These are stronger. Sort of suggests that maybe, well, we'll see. 30-day average, take some of the noise out of it. Still negative. In fact, let's go back and look here. Negative, negative. We were down to minus 12 or so, minus 14, minus 15. Now we're minus 12.46. We've actually gained some ground back, still in negative territory. So, still looks like the active phase of the MJO is in control per the Southern Oscillation Index, even though the models are saying the inactive phase has been in control for a week and a half, 2 weeks, something like that. The 90-day average knocks more of the noise out of it. Good for El Nino monitoring, currently minus 7.77. Where have we been? We've been hanging around the 7 to 8, minus 7 to 8 range for a month now. No signs, if this was minus 12 or 15, then we say El Nino. No signs of El Nino, but certainly no signs of La Nina either. It's not even at 0. We're still negative. So, neutral biased El Nino for the moment in the atmosphere. Kind of interesting, though the ocean sort of looks like La Nina. Is it a temporary trend or is it not? We don't know. Oh, we forgot to look at this, so let's do a quick look. Nino 1.2 sea surface temperature index. So this is sort of like a daily index of what's going on in the whole Nino 1.2 region. That's that area right off the Galapagos, Ecuador, Peru. Noisy area, but gives you sort of a rough sense of the easternmost extent of the Pacific temperature-wise. We were kind of down in a hole in September. We kind of almost broke neutral. But now the past 5 days we're going negative. We're 1.046 degrees below normal today. But in the official El Nino monitoring region, the Nino 3.4 region, from the area south of California out to about the date line, 5 degrees north and south of the equator, the pattern, as we've noticed on all the other charts, steadily upwards since August, but not much. We're plus 0.2, 2600ths of a degree above normal, so basically dead neutral. Okay, well, that's better than being negative. It certainly isn't indicating La Nina like we were here, but it certainly is not indicating El Nino either. Another bit of interesting data, the 30-day Southern Oscillation Index graphed out, okay? So January 2017, we were moving into a La Nina-ish like pattern. We're positive. That's not El Nino. And then in 2018, somewhere around the beginning of 2019, notice the trend is actually downward. Now, I'm scratching my head going, I mean, we've been looking at the numbers every week. Southern Oscillation Index has consistently been negative. You can see the inactive phase of the MJO, the active phase, inactive, active, and we're moving into the inactive phase, but still the average has been below normal in the El Nino territory. If anything, one would think we'd be moving into La Nina, but the data doesn't lie. The atmosphere thinks we're in El Nino. You know what that could be a sign of? Just maybe. Could be a sign of this longer running trend we've been talking about, the PDO, Pacific Decadal Oscillation, which acts in the warm phase, sort of like a long-running El Nino, even though you don't see signals of it, outwardly, like the jet stream and whatnot. The atmosphere sort of gets biased towards El Nino, and if you can get a pulse of the PDO and the active phase of the MJO, or multiple active phases of the MJO, and El Nino going all at once, it sort of acts as an undercurrent amplifier for El Nino. So more to see on this, but just kind of an interesting trend here, certainly inconclusive. And then finally, the forecast for the Nino 3.4 region from the CFS version 2 model, sea surface temperature anomalies, in the official El Nino monitoring region. So we've been laughing at this model, for weeks now, saying this is never going to, the model's been, it went negative in September, and it's in October it says, this spike, we're going to go positive. Well, here we are, we're midway into October. We're nowhere near this. We're probably somewhere right around here, dead neutral. But, it seemed like we were heading towards La Nina, going down into this range. But the model has actually, last week, I think it just had us bobbling around neutral. It's actually come up a little bit, maybe a quarter of a degree above normal the whole way through winter now. And if that were to happen, hey, that's not bad. That's certainly not La Nina. It is certainly not El Nino either, but it's neutral biased warm, which is what everything else is kind of feeling like and acting like, other than that stubborn cool pool that all of a sudden, just like this model said, is starting to dissolve. Now it's not positive, but we're not down here, which it looked like where we were headed. So cautiously optimistic, but the big concern is this developing inactive phase of the MJ will probably push these numbers down some, and then who's to say where we're going to end up. But we're better than where I thought we'd be last week and the week before that. So that's good news, at least neutral. Still, the very weak MJO pattern, not particularly conducive to storm development. You want to see bigger spikes in the MJO than what we're seeing. So for right now, not a whole lot going on in the North Pacific. A little bit of wind swell. Maybe that's about it. Some southern hemi swell is forecast developing under New Zealand. There's actually a tiny little southern hemiswell that's supposed to be moving into mainly Southern California for the coming week. But I mean, small is the operative word. Tropical system off Japan, something to watch. Still nothing really obvious forecast in the North Pacific from like a typical fall winter type perspective. So we're just kind of hanging on the edges here, waiting for fall to get kicked off. Normally, if we were in a good year, it would have already happened. In August, we'd be seeing some sort of, swell activity from the North Pacific. I mean, that's an early season, but typically by September for sure, we've seen nothing. It's like a lake. Kind of disappointing. The other kind of cool indicator, just anecdotally, is when the east coast of the U.S. is good. That means the Atlantic is happening. Typically, California is like a lake. That's exactly what's been going on. There's been since sometime in early September, it's been non-stop on the East Coast. A lot of it wind swell. By California standards, not as good. But any surf on the East Coast, especially if it's consistent chest high, head high, slightly overhead, which it has been, that's been going on. So we'll take that as an indicator and it's still supposed to occur and continue like that for the next week at least, if not more. So probably a sign this inactive phase of the MJO is going to be pretty slow for the Pacific Basin for the month of October. But then after that, things should wake up as we get into November. So take care of business, do what you need to do, and then be prepared for November. Strike when the iron is hot. And so there should be some surf then. El Nino, no, not going to happen. La Nina, though, that's the good news. Maybe not. Maybe we'll eke out this winter just in neutral territory. So that's something to consider and look for the future. All right, that's it for this week. Do this again next week. Same time, same channel. Of course, hit the like button if you like the videos. You can leave comments. We'll reply to them. And if you like, subscribe to this video down on the lower right-hand side over here. There's a bell over there. You have to both subscribe and click the bell. If you do that, you get notifications when we do updates, and then you get an email. So you know, or you can just look at our website, and we post the updates there as well up in the special header section. So that's it for this week. Do it again next week. Same time, same channel. Thanks for watching.